Hi everyone, Syma here from Science of the Times, and in this explainer I'm going to address the question, why is it so hard to kill bacteria? Now, as we all know, bacteria can be good and bacteria can be bad. So there are some bacteria that we really need to help us survive, and we all have a home actually to lots of bacteria, be that in our gut or on our skin. And those are good bacteria that we need. But unfortunately, there's also harmful disease-causing pathogenic bacteria. And I'm sure most of us, probably all of us, have suffered at some point from some infection or another that's been caused by such bacteria. Be that tummy upset, skin infections, or they get us when we're already down and our immune systems are compromised for some other reason. And this is often a problem in hospitals, for example. And unfortunately, oftentimes these the diseases that are caused by these bacteria can lead to fatalities. And that's not only a problem for humans, but also for animals, and they're also a menace for crops and other plants. And so it's something that actually affects and infects the aspect, all life on the planet. And so we could ask ourselves, why is it that they're so difficult to kill? After all, we're sophisticated multicellular organisms and they're made up of just a single cell. So it shouldn't be so difficult to kill them. But it turns out that while on the one hand they are simple, the defense mechanisms that they have at their disposal are anything but simple. And so I'll give you an example. The surface of these bacteria are surrounded by enormously sophisticated architectures. These architectures are multi-layered, so they can be up to 4 different layers. And that's a little bit like saying, if I have a city and that city is protected by some fortification, it's 4 layers of fortification. So an incoming invading army would get through the first wall that surrounds the city, protective wall, then it would be encountered by something else, so water in a moat, for example. They get across that water layer and then they encounter something else, which they then also have to get across, and then something else before they get access into the city. And it's very much a similar scenario for bacteria, but of course at the molecular level. So these bacteria are surrounded by different layers of protection. And so any antibiotic we develop has to be able to penetrate through or punch through these fortifications. And that's not so straightforward to do. Things are even more complicated when bacteria, they actually have something called efflux pumps. What these efflux pumps do is that when the antibiotic is making its way through these fortifications, the efflux pumps recognize them and using energy, so actively pump them straight back out. Okay, so even if we can pat ourselves on the back and say, okay, we've got this antibiotic, it can get through the fortifications, there's a good chance that the bacteria will recognize it as something harmful and pump it straight back out. And actually, when the bacteria recognize that they are under threat from antibiotics or some external stress, they can start to overproduce these efflux pumps, so there's more of them in the fortifications. Of course, bacteria also evolve much faster than we do, and so they can stay one step ahead. Okay, so their lifespan is much shorter, and so they get through many generations much faster, and so mutations that are mutations that are beneficial and that help them to evade the action of antibiotics get incorporated and passed on much faster than they would in humans. Once the antibiotics get into the cell and they start to work on their target, it turns out that the bacteria also can do other things there. For example, they can either neutralize the antibiotic by altering it, or they can change the target itself. So it's a little bit like saying we have some highly sophisticated and accurate missile, and that missile has been programmed to find a specific target inside a city, and off it goes on its journey. But the inhabitants of the city realize it's coming, and they alter the target. So the missile now no longer recognizes it and has nothing to hit. So the bacteria can do that too. Of course, there's a great deal of nuance in all of those mechanisms that I've just described, and we will do a full podcast episode on that soon. But I think it's also interesting to ask, why is it that bacteria have all of these defense mechanisms at their disposal? And it turns out that actually bacteria are probably the most aggressive organisms known. And so even if it was nothing to do with us humans and their encounters with us, bacteria have many different ways of killing each other. Okay, so they often have to survive in with high population densities, in environments that are harsh, nutrients are scarce, and so their different types of bacteria are constantly doing battle with each other for survival. And so if they're aggressive and they have lots of ways to kill each other, in order to survive, of course, they have to also have lots of ways to defend themselves and defense mechanisms. And so that's why they're sort of, if you like, predisposed to have very sophisticated defense mechanisms, which then also, unfortunately for us, helps them to evade our attempts to combat the disease-causing ones. Okay, folks, so I hope I've helped a little bit there and touched on the ways in which bacteria can defend themselves and sort of addressed the question, why are bacteria so hard to kill? Thanks, folks.